SwayamPrabha. Digital India. Educated India.
Welcome to today's lecture on hydraulics and pneumatics. Today's topic will be selection of HST, that is hydrostatic transmission units and components. Now, HST stands for hydrostatic transmission. We have already known that why it is called hydrostatic transmission, because in this case we can neglect the hydrodynamic part performance of such machines only mostly with hydrostatic, not hydrodynamics, except when we are analyzing flow through any orifice or any capillary passages. Now, also we have known what is hydrostatic transmission. Essentially, hydrostatic transmission should have one motor and pump. In that way, any hydraulics and pneumatics drive is hydrostatic drive, because in that case there will be a pump or source of flow and pressure, and that flow and pressure is sent to an actuator which gives some motion. So, in that way we should say every system are hydrostatic transmission in hydraulics and pneumatics. However, when we mean HST transmissions, then basically we mean there is a rotary pump and rotary motor, and these pumps and motors, they are they may be identical looking, their body, the reciprocating units, valve, etc., they may look alike. In fact, the same components can be used for pump and motor, except there is some differences in the flow distributor valves. And even it is possible that we can combine that pump and motor together, and that unit can be used both as pump and motor. Anyway, this what we look in this figure, that there is basically a pump is there. This is driven by some prime mover, and then there is an reservoir and oil is going in. Then oil is transmitted to the motor part, and which actuates, this means that rotates, and the oil goes out to the reservoir. So, this we should say an open circuit. It is also possible that we can, instead of using that reservoir, we can drive this pump which can be rotated in both directions by some arrangement is there, and that is driving a motor, and depending on the direction of flow, that motor will rotate in both the directions. That means, it can rotate, it can be rotated in clockwise direction as well as in anti-clockwise directions. It is not necessarily that prime mover is rotating in both directions. Prime mover may be rotating in one direction only, and there is a mechanism in the pump by which we can change the direction of flow. That means, it can be flowing out this way, or it can be flowing out, it is flowing out from the other sides. So, this is called closed circuit. So, if we mean that hydrostatic transmission, then we either we mean to this open circuit or to the closed circuits. Okay. Now, this is open circuit, also open loop without feedback, there is no feedback, open circuit and open loop. Then we would say this one is the closed loop, closed circuit and open loop, that means without any feedback. If there is feedback, then we will call it is a closed circuit, closed loop, etc. We are coming to that. Now, this is already we have seen. So, this is open circuit, open loop without feedback. Then we can have the open circuit, closed loop with feedback. So, there is a feedback. So, this means that depending on the output of the motor, this pump can be controlled. So, this is open circuit, closed loop. Similarly, we can have the it is a closed circuit, but open loop, and finally, we can have closed circuit, closed loop with feedback. That means, this is not only closed circuit as well as closed loop. So, first part, this term is the circuit term and second part is the control term. In that way, we can name like this. So, if we are asked, usually in the classroom question paper or the examinations, these are a popular questions that describe the hydrostatic transmission system. Then you have to write all such things with such simple diagram. Okay. And finally, we can make a block diagram like this. Hydrostatic transmission systems, you see, when we use HST term, many people write that a hydrostatic transmission system. No, it is not for hydrostatic transmission system. HST word comes from hydrostatic transmission only. The S, the static, that S is here. Now, when we add the systems, then S will come here. So, this HSTS means hydrostatic transmission systems. Now, as we have seen, the piping term or circuit term, open circuit, discontinued flow, interrupted flow, and closed circuit, continued flow, uninterrupted flow. And then both may be open loop, no feedback, closed loop with feedback. This part is also same. Now, in reality, circuit will look like this. This is a simple open circuit, consists of the following major elements. What is that? There is a reservoir, then suction strainer, these are called suction strainer too. This is filtration is usually 100 to 200 micron in general purpose oil hydraulic applications. Now, what does it mean? This mesh of the, usually the wire mesh is used, also filter papers are used, then it is 100 to 200 micron. Say if we consider the 100 micron, that means within 1 inch there will be 100 mesh, it is like that. So, you can imagine how small particles they are being filtered. This particle size, say maximum size is 200 micron. That means, if you think of a square mesh, then diagonal length is equal to 200 micron approximately, you can imagine in that way. Now, third one is the pressure relief valve. This one is the pressure relief valve. In this case, system is like that. We have a pump source, there is a filter, and then it is going into a valve, which is in 5th item, 7th actually. Then pump fixed or variable, this one. This may be fixed or may be variable also, and then motor fixed or variable displacement. This one may be fixed or variable. That means that swept volume may be fixed or may be varying. Now, this conduit etc. are means this piping, this may be rigid as well as flexible. Then return line filter, this is usually 10 to 25 micron. Now, why it is like that? Now, actually this strainer is used, it has practically it is not required. Only thing, due to safety reason we put it there. That means, if there is any big particle that is being filtered, that should be filtered, otherwise pump will be damaged. But actual filtration is done in the return lines, because why in the return lines? If we put such a strainer at the inlet, then this pump will need very high power. So, to avoid that, and then there will be loss. To avoid that, we put in the return line, and this is also justified because there is no exposure up to this motor part that the dart can come inside. But in case of motor, usually that output shaft is rotating, and then through that some dart particle may come inside, because there is a exposure. The output is that external to the from the enclosed body, although there is the sealing, but there is a possibility of dart coming inside, and that is being filtered in the return line. Next, the control unit. This is the control unit. Control unit is actually the valve. The first day we have seen that how this valve is functioning, but here I would like to say, with this arrangement you can see this is a tandem type valve. That means, in normal time this oil will go to the tank and these two will remain closed, but if we actuate in these directions, then oil will go to this and it will come back through this, and then say for this it is a clockwise rotation, and for this function it will rotate in the opposite directions. Now, these are the two valves are used, that is relief valve. That means, oil is being relieved from here to here. So, this is although open loop, but it can be said with this feature, it is somewhat acting as a closed not loop, closed circuit also. However, we can use this filtration line also other place, that I will show. Now, what if we would like to construct a closed circuit? In that case, the pump, this arrow means variable displacement pump we are using, and this pump is being driven by the prime mover, and then these are directly connected to the motor. Two ends of this pump is connected to the two ends of the motor. Now, depending on the direction of flow, which again can be controlled by this control, not changing the direction of rotation of the prime mover, we can change the direction of the motor rotation. Now, if we look into the circuit, then we will find many things inside. What these are? There will be leakages in any hydraulic components, we cannot avoid that. Now, this leakage to be compensated, for that we need a feed pump. This feed pump means it is only compensating the leakage flow. So, capacity of this pump is both pressure wise and the flow wise is very small pump. So, and it is usually connected to the main pump also. So, through the same shaft it is connected. Now, this is connected, inlet is connected to the reservoir, and from there oil is being pumped to this circuit to compensate the leakage, and there is a relief valve. The excess oil, it is going back to the tank. In fact, excess oil is coming to this casing in this diagram. It can be directly coming out, or through this casing it is coming out to the oil, because for such components usually casing where the automatic leakage is being there is leakage, and that always to be kept filled for the lubrication purpose. So, this arrangement is shown like this. And then what we find, the two non-return valve. Suppose the oil is going through this, or from the pump it is flowing like this, that this means that this is a high pressure oil, because it is rotating the motor. So, due to this high pressure, this will remain closed and oil will go through this check valve or non-return valve to this side. Like this means that high pressure oil is directly sent to this motor for rotating, and if there is any leakage, that is being compensated here, and then again it is being fed to the pump. This means that there will be no shortage of oil in this circuit. If this oil moves in other directions, then this side will remain closed and oil will be fed through this. Okay. So, this is to compensate leakage, we need a feed pump. Next, we this is called dual shock valve. These are nothing but two relief valves. This relief valves means if there is this pressure exceeds the need of the motor, that means system pressure, then oil will directly go back to this part of the circuit, and it will go back to the tank, and this motor will stall. Similarly, when it is trying to rotate in the opposite directions, it will go to the other part of the pump. So, this would operate, but time to time we need to bypass the oil to the tank, and for that this system is there, and this is again sent by the system pressure. In that case, what will happen? Oil will go back to the tank. So, minimum requirements for such a circuit should be like this. Okay. Function of this part is that due to the high pressure, this will operate and oil will go through this setting pressure. This is set at the system pressure, it will go back to the tank. Say for example, this is operating at 10 megapascal. Suppose due to some reason, due to high load, it has exceeded 10 megapascal. Then in that case, oil will bypass through this, may bypass through this, otherwise it will go to the other side of the circuit. So, here the pump is also stalled, oil has to pass through this. However, it is possible that without this we can have this system, but if using this is a foolproof circuit, means the pump and no components will be damaged, oil will go back to the tank. Now, these components are feed or charge pump, this is called feed pump or charge pump. Then dual shock valve, it is called dual shock valve, protect the system from the damage in case of pressure override and overrunning conditions. To improve the performance and to fulfill other desired tasks, many other appropriate components such as accumulator, cooling system, special purpose valves, etc., are included in these circuits. Say this is the minimum, but we can use, say for example, for smooth performance we can add accumulator, to cool the oil we can add the cooler. This means that in that path, on the return path there will be a cooler, like that. Now, we shall look into the circuits. We have seen few circuits, as well as we have seen that the motor, open circuit, closed circuit, etc. Now, depending on different types of loads, the HST system employed may be of different types. But here we are discussing the type of closed circuit, because this when we normally call hydrostatic transmission system for driving say earth moving equipment, for driving a tractor, for driving a say forklift truck. In that case we mean closed circuit, may not be closed loop, but it is essentially a closed circuit. So, if you consider the closed circuit hydrostatic transmission system, then the displacement of pump and motor, we will consider the what type of displacement is there, then transmission type, and from there we will look into this what are the different types. Now, first one is that pump is fixed displacement, motor is also fixed displacement. Fixed displacement means it is having constant swept volume. What is constant swept volume? Swept volume is the volume displacement by one revolution, whether it is motor or whether it is pump. So, only one revolution, whatever the geometric displacement, that is called the swept volume without considering any leakage. Now, if that remain fixed, in that case we should call fixed displacement. Again, with some mechanism it can be varied, that means in a revolution that total displacement will vary, we should call them variable displacement. So, here we understand now what is fixed displacement. We have fixed displacement pump, fixed displacement motor. So, power in that case will be constant, torque will also be constant. Obviously, this is for a constant pressure. Then output speed is also constant, and commonly we call as a ordinary simple circuit. Next, if we consider pump is variable and then motor is fixed, then power will be also variable. However, it will be usually for constant torque. That means, when the pressure is constant, then torque is also in motor it is a constant, but we are varying this power. So, output speed will be variable in that case. Then we call it constant torque system. Next, what we get? Fixed pump, variable motor, and in that case power remain constant. With that constant power, torque can be varied. This is also variable, and we should call it constant power system. You will find that this is a simple system, first one. Second one is very widely used, but looking into some, you should say that power saving system, this is not suitable for where the torque is very wide range. It is may be controversial, but I would say this is power is varying, but range is not that high, and we can go for such system. This is also used, but in that way I would say we can make all variable. Now, all variable means then we can keep at a certain position. So, this will be fixed, this will be fixed, or it might be variable, this is fixed. This means that if we make this one variable, then we can have all three pressures out of this. Now, this has no special name. This can be made constant power system, this can be made constant torque system, or an ordinary system, but this will be definitely expensive. Otherwise, I would suggest in every case we can go for such arrangement, but if it is not required, not much variation in power and torque is there, we need not go for such a system, because this will be expensive. Now, we shall look into the selection of such components through and work out an example. Now, this let us see this what problem is there. The drum of a concrete truck mixture is lined with spiral vanes. This means you might have seen a big truck with a rotating drum, it is moving, say it is carrying cement, you will find the cement. What it is there? The cement mixture that is done at one place and that is being carried to other place, but it should not that means it will, if you do not rotate it, then this may solidify, I mean it will take the concrete shape. To avoid that, it is done. Also this is used for cement manufacturing, when the cement is being manufactured, for that purpose also. This might, there might be something else also. So, there we use a drum which should be rotated and while it is being carried. Now, this drum is rotated in one direction. If it is rotated in one direction, the vanes force the mixture downwards and mix it. It is mixing. Now, for unloading, what it is rotated in, at high speed in other direction. They lift the concrete mixture and discharge it. It is like that, at one place it is being mixed, then it is being carried and then it is being mixed, going up and down. Detailed arrangement I cannot explain here, but it is like that. However, while it is carrying, in that case it should only just move, so that I mean some we are just mixing like this, vanes are rotating like the inside, and these are not allowed to being coagulate. It is like that. So, that is called agitating speed. To prevent the concrete settling or setting while transported, the drum is rotated at slow speed to agitate the mixture. Definitely, we need not rotate at high speed, neither we need that much power at that time. The drum drive is done through an HST system and gear reductions. The variable displacement pump, we have a variable displacement pump of HST system is driven by the main engine of the truck. Characteristics of pump and motor are shown in figure. There is a figure in next slides. Now, the drive system maintains the agitating speed range unless the engine is stopped. This is important. That means, if you suppose you are not moving, you have stopped the car not moving, but engine it is not stopped. That speed usually you know for any car, that is low speed, not high speed. At this speed, the agitating operation should continue. That means, drum will rotate. So, this means that. Now, data for the mixture drive system is that maximum drum speed is 15 rpm, that means, when it is mixing or discharging. Drum agitating speed is 5 rpm only, 1/3 of that. Overall gear reduction ratio is 1:30. This means that from the motor output, hydrostatic transmission motor output, there is another gear reduction 1:30. So, that we can have 15 rpm. Otherwise, directly by the motor 15 rpm is very difficult. Performance of this motor will be then very poor. That is why we use a gearbox. So, 1:30 gear ratio is there. Maximum running torque is 1200 deca-Newton meter. The value is given in deca-Newton meter. Now, find out pressures, different speeds of the engine, pump, motor, etc., and powers, both running speeds of drum. That means, normal running speed as well as agitating speed. Assume 100% efficiencies in all units except the hydraulic motor. Now, I would say that every that rotating units, or maybe even ordinary units, as having its own efficiencies. Say for example, this motor, it cannot run at 100% efficiency. That means, there will be losses. Losses may be leakage, losses, mechanical losses, that is which the friction losses, and also there is called hydraulic losses. Not is in this lecture, we shall discuss maybe in other lectures that what are the losses. Now, leakage loss you can understand what it is. Mechanical loss means there will be friction loss and such mainly friction loss, we should say mechanical, also thermal loss will be there in other form. Then there is a hydraulic loss. Hydraulic loss is usually that fluid is, although we consider the hydraulic fluid is incompressible, but it will be compressed a little bit. So, there will be some loss. Also the body of the conduit, say particularly flexible hose, that will be also expand. So, there will be some loss. So, that normally put into hydraulic loss. It is very difficult to calculate all such losses separately, but we can experimentally we can find out what are the total losses. Also we have to make a circuit for this. Now, here we have considered the variable displacement pump. In that case, we have considered the swash plate type pump, which we can move, and by that we can increase or reduce the swept volume. Now, the characteristics of this pump is shown here. That means, this chart is available from the manufacturer, and while we select a components, we have to look into this. Say for example, here this flow output are given, but that you can see against this RPM of the pump input and against the pressure. Say if it is a maximum pressure is 6000 pound per square inch, in that case you will find that we have to follow this line. Now, if the pressure is very low, then definitely that higher flow is available at lower speed. Okay. And these lines are the power. Say power will vary at different pressure following these lines at different RPM. So, this is the pump characteristics. And motor, what we have used, this is called orbit motor, which is low speed high torque. That means, this can give output of very high torque at low speed. As you can see, the maximum speed, continuous speed only 500 RPM, whereas that pump you have seen 2000 RPM or more. And this you can see this torque is 60 decanewton meter continuous, and for intermittent it may be up to 625 RPM and output torque is 65. So, here A is continuous up to this point. So, we will normally follow this curve for continuous operations. I mean this portion is for continuous operations. However, we can either increase this, maybe both cannot be increased, we can increase the speed or we can increase the torque up to this limit. Okay. That is for few seconds only, maybe at the starting or so 10-15 seconds it can run at high speed or at high torque. So, we are using this type of a motor. Now, the solution will be like this. The given data are maximum drum speed 15 RPM, drum agitating speed is 5 RPM, overall transmission ratio of the gear unit is 30, maximum output torque we need 1200 decanewton meter, 100% efficiencies for all components. This is for the solution purpose we have considered like this. Actually, we should consider efficiencies of all. However, we have considered that hydraulic motor we should consider its efficiency. I will show that how the calculation is done. Now, what we have to find that pressures, different speeds of engine, pump, motor, etc., powers, and also we have to draw the circuit. Now, motor speed at maximum drum speed is, we would say, 15 into the transmission ratio 450 rpm. That means, we should motor output speed maximum, that is while it is mixing or maybe discharging. Definitely at the time of mixing the more power will be required. Look at this, how this is the inclined. It is arranged in such a way, it is mixing, the materials are moving normally downward directions, because that time we need more force. So, gravity force helps for mixing, while we are discharging it, probably it is not mixing. So, some power optimization is there, but anyway we do not know. Maximum torque will be 1200 decanewton meter. Now, motor speed at agitating drum speed is 5 into 30, 150 rpm. Now, maximum running torque 1200 decanewton meter gives maximum motor torque. Okay. Now, definitely if this is the output torque, then input output from the motor should be 1200 divided by the transmission ratio. So, 40 decanewton meter, assuming 100% transmission efficiency. Now, here that gearbox efficiency we have considered 100%. So, we would say if the motor can transmit 40 decanewton meter, it can output is 40 decanewton meter, then it is it will suffice the purpose. Now, looking into this curve, we will look into this motor curve, motor characteristics curve. Then 450 rpm is here, because we need 450 rpm. So, we will follow this line, and then torque is 40 decanewton meter. So, we will find that this is our operating point. Now, at that operating point we will find the power, etc. We will look into this. So, from this graph what we find, maximum power 18.85 kilowatt. How I have done, can you see this? This is 20 kilowatt and this is 15 kilowatt, and we have to estimate from these two curves. It is to me it is around 18.85 kilowatt. Okay. And what is the pressure? This is 140 bar means 14 megapascal. So, therefore, it is around 14.8 megapascal we have estimated. So, this much, this means that this line, if you look into this, from low speed to high speed, this slightly bending, this line is iso pressure lines. Okay. So, here we consider that this is the pressure. Now, this is again, this is not the output pressure or so, it is called a differential pressure. That means, when in a motor, oil in and oil out, when the oil out, there is also some pressure, because there is a filter and other components. So, oil in, that pressure should be higher. That means, to know what is the actual pressure input to this motor, we need to know output what is the pressure. In case of closed circuit, it will be always there. So, it is estimated, we have to calculate considering these two pressure. In open circuit, somewhat we may consider that outlet pressure is very low. Anyway, this remains unknown in this problem. However, we know this is actual characteristics, it is on experiments. So, we can say that this is the power output, and the flow is 95 liter per minute. How we can find out the flow? This is 100 liter per minute and this is 80 liter per minute, and we have estimated this is 95 liter per minute. Now, input power to motor, pressure into flow we can say. So, what we find, it is 23.43 kilowatt. You can simply calculate like this. Pressure into flow will give you the power. 60 is for per second, to calculate this power per second. This is megapascal we have written, and this is liter per minute. If you directly divide by that, automatically you are going to how much kilowatt is there. Then from the chart what we find, output of this motor is 14.8, which is directly can be found out from 450 rpm into the torque available. Available speed and available torque will give us this power. So, this means that definitely there is a efficiency, matter of efficiency, overall efficiency. That efficiency what we calculate 80.5. Now, if we look into this, say this is ISO efficiency lines, this is 80% and this is 85%. That means, if motor operates within this zone, it is 85%. If it operates within this zone, then you can say something between 80 to 85%. And we can see this is 80.5. So, this is 80 line, but it is coming 80.5, maybe some estimation it is slightly wrong, but we can say if this is 85, this is 80, this will be something in between. So, it is maybe 81 or 82%. Okay. So, our calculation is going in the right directions, and we can say that we have estimated more or less correctly. So, this motor can supply this maximum torque required. Okay. Now, if we consider that agitating, this is an 150, but we have not said how much torque is required. Now, in that case, the material is not moving this way or that way, not going up, not going down. It is just simply, maybe that time drum is kept more or less horizontal, and it is just rotating, not to allowing setting it. In that case, let us consider the half of the torque will be required. We have assumed this one. Sorry, in that case, what we find that it is the maximum efficiency zone. If you look into this, you will find that one is the maximum efficiency zone. We will come into the next the slides later again. Now, again we are continuing. Now, motor differential pressure is 14.8 megapascal and input flow to the motor is 95 LPM. It is clear that pump output flow must be 95 liter per minute. That we have seen that we need 95, this is the actual chart. So, 95 liter per minute, that is fixed. However, to have motor differential pressure 14.8 megapascal, it may need to pump deliver the flow at higher pressure, which depends on different losses, that is unknown. But we will consider, let us consider, as we have considered the efficiency of the pump is 100%. So, it will be 14.8. It is assumed that pressure at motor outlet is 0. If we assume in that way, then as 100% efficiencies for all other components, we will now consider that pressure output is 14 from the pump is 14.8 megapascal itself. Now, it is equivalent to 2114 psi, that is pound force per inch square. Now, how to calculate this? Roughly you can say 1000 psi is equal to 7 megapascal, 1000 psi is equal to 7 megapascal. Then while delivering output flow is equal to 95 liter per minute, assuming this is an imperial gallons, then we will consider divide by 4.5 will give you gallon per minute. Okay. So, this we need this one pump flow output and pump pressure output. Now, we shall look into the pump chart. First, we will consider that the flow. For that flow, we have to assume that for 2114 psi, where may be the line. So, this blue line is there. Okay. Then we will consider the flow. This is 20, this is 25. So, 21.1 gallon per minute. Then that intersection point is our this output point in terms of flow output at that pressure. Now, from there if we come down, then we will find that RPM is around 2050. That is all I estimation. One can calculate by measuring a scale and then calculating. From my IA estimation, it is 2050 RPM of this pump. Then we shall consider the power. How to estimate the power? Again, we will consider this 2114 psi. This might be this line. Okay. Then this is the point where the power to estimate the power, and we are getting this is 31. This is in horsepower. Oh, sorry, this in horsepower. 30 horsepower means what will be in kilowatt? 1.6 horsepower is equal to 1 kilowatt, isn't it? 1.6. So, 30 divided by 1.6, around 18, what we have calculated there. Okay. So, I think this is, we made a mistake here. So, it is not 31 kilowatt, this will be 31 HP, around 31 HP. So, this will be 18 or 20 kilowatt or like this, but actually if we carefully consider, we will find it will be 23 kilowatt what we have calculated in terms of flow and pressure. As we have neglected the efficiency, these results are coming in this way. Now, therefore, speed of the pump at maximum drum speed is 2500 rpm and it is 31 HP. So, this please note these corrections. Engine to be operated at same speed and power. So, that is we have selected the engine like that. Now, for agitating speed, say this speed was, as you see, this is for motor specification for normal operations, but for agitating speed what we found that 150 rpm and this is the torque. Okay. Now, here I would say looking into this rpm is 150 and here rpm is 450. So, just it is 3 times less. Also output speed was 15 and 5. So, we may be tempted that in that case the flow will be just 3 times less, and as the torque is half, then maybe we can consider the power is totally 6 times less, but actually it is not, because due to the efficiency factor we have to again reconsider this. We will find that there at that speed loss is not much, and again this agitating speed, it is the normal, say this is carrying for quite a long distance. That time we would try to utilize the power in such a way, this is at the maximum efficiency zone. So, it is designed accordingly. Okay. So, this efficiency apparently it is close to the 100%, but it will never happen, because this here it is this line is 87%, and within this zone it may be at the most 90% efficiency, but never 100%. So, we would say this it is with 90% efficiency it is operating. So, again we have to find out the power in the same way what we did earlier. Okay. Now, the agitating torque is assumed, this 20 decanewton meter we have assumed. From the graph, then this is 31 liter per minute and pressure is 7 megapascal. What we find that 70 bar means 7 megapascal, and power we find it's 3.15 kilowatt. But hydraulic power is 3.6 kilowatt, calculating from the flow and pressure term. Okay. Therefore, efficiency is around 87.5%. So, within this zone even the efficiency is showing like this, not showing 100%, and this is seems to be correct. Pump output 31 liter per minute, 8.89 gallon per minute, and pressure is 7 megapascals. So, if I consider in the same way what we have calculated, now this is the line for the flow term, and on which this is the pressure term, and we get this point there. Okay. And then speed we find 600 rpm. If you have any idea about this engine, industrial diesel engine or so, you will find normally 600 to 700 their idle speed, you will find that. So, 600 speed, when even if the truck is not moving, we can have that speed and we can have that power to for the purpose of agitating. Now, this is 600 rpm, and again if we consider the 1000 pound per inch square, and then we found this power is actually again this is not 3.6 kilowatt, it is around, you can find around 5 HP, which is 5 divided by 1.6 is will be something like this, of course. But this is a mistake, by mistake I wrote like this, actual may be slightly different from that. Now, we have to draw the diagram of circuit. Now, normally if you would like to make an open circuit, what you can do, you can choose the same circuit what we have seen, but instead of using the relief valve here, we can add one relief valve there. Okay. So, this is open circuit we have considered. However, instead of that, whatever original was there, we can use that one also. This circuit, mind it, this is only for rotating the drum, this is not driving the truck. For truck, from engine there is a separate drive line, it might be that ordinary speed gearbox, and there is differential, etc., etc., not hydrostatic transmission. Hydrostatic transmission system is, although the same engine is the power source, but this circuit is only for rotating the drum. Now, as well what we can do, instead of this variable, here the pump is variable displacement, instead of variable displacement pump, we can use a flow control valve is also there, that is another possibility. Now, you should keep in mind, if there is a pressure setting, say for example, this pressure setting we have seen 7 megapascal. So, this pressure setting not 7 megapascal for agitating, but 14 point something for the maximum torque. So, it might be set at 15 megapascal. Okay. If you use this flow control valve, your excess flow will always go through this relief valve by blowing this relief valve. That means, pump to this point always pressure will be 15 megapascal. In that case, the loss will be more, but the advantage is that this oil is always ready with the pressure. So, performance of this part will be better. So, usually if we would like to rotate for a very short time output, flow control valve will be better than this variable displacement pump. Variable displacement pump, you have to make the pressure ready, everything. So, there will be a sluggishness in the response. So, these are the differences. Anyway, depending on the cost optimization, you can select which one to be used. Now, again this while you are trying to answer such a questions, you should name all the components like this. This is same as what we have discussed earlier. Now, also we can go for closed circuit. Mainly we may choose the closed circuit for this particular transmission, because we have seen that this while it is mixing and while it is discharging, it is having motion in both directions. You need clockwise and anti-clockwise output, and that might be not for longer time. I mean time period, it is like that for a few minutes you are rotating in clockwise and few minutes in the opposite directions. So, looking into this, maybe closed circuit is the better option. In that case, as I have told that this you may use or may not use, but it is better to use this for more safety. This is considering safety of whole circuit. Okay. So, while you are answering, you may draw such a circuit that this will be for the drum drive, and drum a gearbox is connected here, after that drum is connected there. So, if we come either this circuit or this circuit, anything will do. You can answer. If you answer both, showing that, and you can discuss, so your answer will be better. That is all. So, thank you very much for listening.